Okay, so we are on scenario 5. All right. So a pharmacokinetic study was determined following a 300 milligram IV bolus dose, and the equation describing the drug equation, the equation describing drug concentration is this one. Okay. So first off, how do they get these? I'm just gonna go take a side detour, not solve the problem, and just show you guys really quickly. So I did this in my lab all the time. I would get a rat, put him in a cage, give him a nice amount of drug. He's got whiskers and big ears. And then I would see, how Mr. Mousy take blood samples, and they didn't like that. That's our mouse in a cage. And so I would find that, all right, drug concentration's there after an hour, and then there, and then there, and then there, and then there, and put it into an Excel sheet. Make a graph, and choose the best fit line. And so when you do that, you get these lovely equations, which are very helpful for you to find out all this stuff. So that's the real world application that you guys don't care about because you guys have an exam tomorrow. Ha! Me trying to teach you. That's okay. I'm just a fellow student. I'm an idiot. I don't mind if you disregard everything I say. I just have a hunger for learning. So, what is the volume and distribution for this drug? So, before I get there, which equation are we going to do? We are going to do, we are going to look at this right off the bat. So, this equation right here, this one, that is an awful arrow. This one right here, much better. All right, so that is this equation, which is the drug dose over volume and distribution equals e to the negative ke t. So we're given the clearance. So this is clearance. But clearance happens to equal d over vd. And we're being asked to find this thing, volume of distribution. So we take 47.2 milligrams per liter, and they already told us in the thing that they gave us a big dose of 300 milligrams. So now we just have to find the liters, x liters. So volume of distribution. So we take and move all this around, and we find that 300 can move very nicely over 47.2 milligrams per liter. And then these cancel out and it just leaves liters. So when you enter that into your calculator, that's 300 divided by 47.2, and you should get 66.356 liters. So we found our volume of distribution. Yay! All right, what is the elimination? What is the half-life for this drug? Well, we happen to have Ke right there. So this is really, really simple. Lovely. We love simple. So you take T 1/2 is equal to ln of 2 over Ke. That's the equation that we're going to use. We just said that Ke is this thing right there next to the little t. So I'm going to write down here T 1/2 is equal to ln of 2 over, where are my notes? 0.1421, and that is equal to 4.877 hours if you put that into your calculator. All right, and number 9. What is the drug concentration 8 hours after the dose administered? So this one's a little bit more complicated, but thank God, we have the master equation. We just have to plug and chug. Well, what are we plugging? Let me make this a little bit clearer. We are just going to be plugging T to find what time 8 hours are. So, awesome. So C of T, 47.2 milligrams a liter. Let me put those in a little parentheses. Negative point. My one's looking like a derpy 4. All right, 21 times 8. So let me plug that into my calculator, move that over so you guys can see what I'm doing. Crap. Is that right with my notes? Yes, that is. So we find that concentration at said 8 hours after the dose is administered is 15.144 milligrams per liter. Remember your units, people. It will save your butt. Trust me. And so from the equation sheet, this is the equation we're talking about. That's the one that we're doing all in this section.